Hi, welcome back to Rust Club. Today we're talking about error handling. In Rust, we use the result type for error handling. Once you start using result, you'll probably have some questions like, what should the result's error type be? And what should I do if the code actually returns that error? There's no general purpose one-size-fits-all answer to these questions. It kind of depends on what you're building and who's actually using your software. A web server and a general purpose library and a CLI application, they all have different users. And those users are going to need their errors handled in different ways. So in this video, we're going to talk about some different error handling strategies you can use and why you choose one over the other. As always, these videos are recordings of a live chat between KittyCAD employees. We're all doing this live. So people are going to be asking questions, figuring out some related topics, debugging problems in real time because we're actually live coding everything. So you got the chance to see me make some mistakes and figure out how to debug them. I hope you find this video helpful. Cool. Yeah, there's like an idea of like errors versus exceptions that some people think is a really significant distinction. I can never remember which one is which, but there's the idea that you have like errors that are part of normal operation. Like if you're writing like TCP stack, there are errors you should expect all the time. Like, the other end is not ready for more data. That's an error, but it's an expected error and you should handle it. Or, you're writing a web server and the client hung up before the request was completed. That's a totally expected normal error and that should be considered like party error, like a normal event to handle. But on the other hand, there are exceptions, like something that you think will always happen, but it actually doesn't happen. So, like a key resource that you need not being found on the file system, like when the engine tries to load a shader and it can't. Like those indicate serious programming errors, not just an expected part of work that you have to handle normally. So, I think you should be if it's a normal error that happens, then you have to manage it. You should never be panicking or unwrapping on that. But if it's an exception where you don't ever expect it to happen, sometimes there's nothing else you can really do but panic because there's no way for the work to continue. Like in the engine, we have this single-threaded engine actor that is in charge of serializing all the calls to the engine. And if that ever panics, we can't get any more engine work done. The best thing to do is just panic and let the whole process crash in that case, because that way it'll get restarted by Kubernetes and we can, get a new engine spun up. If we had a better way to handle it, I would like that, but we do not. So, yeah.
One thing
thoughts
that
about
you
this?
said is interesting to me because we've talked about how you should be diligent on where you panic, but I think it's not always clear to me that unwrapping anytime you unwrap is exposing yourself to a panic. Is that the idea? We should be really careful about using unwrap at all.
Yeah, in Rust, unwrap is just like, panic if this enum is the wrong case.
And that's the question mark, right? Which is like very, very.
No. So question mark is not
Oh, my
unwrapping.
bad. Okay.
So the question mark is going to check if it's okay, and if not, it'll throw the error up caller. I mean, throw is like an exception kind of word, so it's not really throwing. It's early termination.
Okay, great.
Yeah, it's terminating the function early, but the process itself doesn't crash or anything.
Great. I thought you were
Yeah.
saying the question mark was like risky, this like thing that is everywhere.
No. Exactly. The fact that it's everywhere and it's kind of only one character makes it kind of blend into the background a little bit because it's supposed to be kind of normal syntax, normal part of error flow. And so like the dot unwrap or dot expect, those are much longer and scarier and they kind of stand out a lot more. It's like a whole word, not just one little sigil at the end of an expression. Yeah, Jess, did you have anything you wanted to add to the topic?
No, not that I can think of.
Okay. Well, we can take a look at some Rust code then if you want to do that? Or we can keep talking about kind of general error handling philosophy.
I have one question about error handling, the library thing.
Yeah.
The idea that libraries should try not to panic ever. How does that practically result in things that uh, there are cases that I can think of where a library doesn't really like have control over part of its domain, so like a file reading library or anything like that. So in those cases, they can't do any more work, but you still think because they're a library, they should always be responsible with like that potential error state. They should treat those as like still within their control to like pass along and leave.
Yeah. Yeah, I do, because the library doesn't necessarily know how it's going to be used. Maybe you have a library that is designed for like one specific kind of use case, and you know in that use case to kind of panic.
But
But
then why are you
generally,
writing
I'd say,
library?
well, yeah, I mean, something that's like so general purpose, like just reading a file, you know, in like in our servers, in the engine server, when you're converting files, you know, you always expect the file that you've converted to be at a certain path. And so when there's no file at the path, it's definitely an error. But you still don't want to panic because that would crash the engine for all the other people who are trying to use it concurrently, right? You should just kind of fail that request, just return an error like an HTTP 500. Ooh, we made a little fucky wucky, and just move on after that. But panicking is going to like terminate everyone's like in progress streams or like actively going on. So panic is like way overkill for this kind of error.
Okay, that makes sense.
Yeah. The other thing about errors is uh, if you're going to return an error upwards to the caller, you have to make it easy for the caller to interpret what kind of error that was. So it's important that your errors are structured. They're not just a string. Because trying to tell what kind of error something is from a string means you have to do like an exact string comparison. And then, of course, someone in the library is like, oh, we made a little typo in here, or I want to tweak the error message slightly. And then all of your string comparisons break. And so you try to make your string comparisons a little more resilient by doing like if error dot contains file not found. But then again, you're like, you're not really fixing the underlying problem, right? What if someone changes the message to the file itself was not here or something? So I much, 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 much prefer like structured error handling where each error can be like inspected separately, but the type of the error is separate from the presentation of the error to the user. So there's a lot of different patterns you can use to do this. You can have an error enum where every variant is its own type of error, or you could have a struct with an error code. So I'll just like demonstrate briefly. Like two common ways I find myself writing errors, depending on the application. In Rust, at least, we either have error and we have like file not found, or we have like permissions error, say. Or we can have something like struct error message string code size. Let's make this error 2. So in both these, we can separate the like specific kind of error from the presentation. We can just derive two strings both of them. So there's going to output a string, and it's going to call the the format call again. So let's have so I can just do like a normal pattern match on the error if they got one. So we can have like let's just actually to do this out. So you can just match on E and you can check, okay, if something went wrong. Here, let's have so if something goes wrong, it's going to return this kind of error here. And now I can check, okay, what actually went wrong? We can say if let error equals write my file. And now I can handle these two different kinds of errors separately. Like maybe if the file isn't found, we retry and wait up a second to see if another thread that was running the file can get to it, right? So let's actually match on this. So if the file isn't found, we're going to just sleep and retry. But if there's a duration error, then there's nothing the program can do about that, right? So we may as well say like, just panic. Yeah, so here we can see that by having the ability to actually like check what type of error it is, you can act differently without having to look at the specific kind of string error message up here. It's really good because not every error will result in a panic. Some of them will. Like if you don't have permission to write a file, okay, like you're straight out of luck. You can't do anything about that. But if the file's not there, you can always try to handle it by waiting for something, or you can rerun the function again, maybe instead. Yeah. And then this is just kind of a different way of doing it in languages besides Rust. And you could just have something like file not found constructor, which is going to return message could not open file, and we'll have a code for each one.
Thing I find perilous about error codes is that you have to have like a shared agreement of language now about the codes. Like I know we've talked about the how shell scripts, any non-zero return value is an error, and like there is zero agreement on what those numbers mean.
Yeah.
I feel like I'm remembering that correctly, right?
Yeah,
I didn't
absolutely.
know that until we discussed that.
Yeah, you just have to look up in the man page like what the given command's problem is for error number 303305. But if you're working within Rust, it's why I prefer to match on error enums, because that way it's pretty clear what you're matching over. You're matching over file not found. It's clear how to handle it. If we were going to use this error 2 instead, we'd have to, as Frank says, we'd have to have like some way of mapping the error code back to the error message, or back to like what we want to do to handle it. So if this returned error 2 instead, we'd have to match on the code field. Oh,
And you would always need a catch-all because now it's an int.
Yeah, exactly.
But do you prefer to match on enums even in a domain like the web, like where there are fairly well established error codes?
So even with the well-established error codes of the web, um, and so yeah, just to quickly finish this little thing,
Oh yeah, sorry.
let's just put like uh, unknown error code. Yeah, so long error codes means you have to handle what happens if you get a weird code you don't understand, and we have to have something to maintain these two, like the mapping from numbers into errors, and then over here we have the mapping from errors into numbers. We could break that into a shared library where each part has like a, maybe something like function from code, where we then take in a code, we can try to encapsulate it nicely, and we match over the code here. But you're still gonna like ultimately be stuck with the problem of, the type system has no idea what the set of valid codes are. Whereas in the enum case, the type system perfectly understands what the valid error variants are. So yeah, Frank brings up a really good point, which is in some domains like HTTP, there are already really well-known error codes that are kind of canonical, like 404 for page not found or 500 for internal server errors. But I find that even with that, I usually end up building my own error system because from like a point of view, if you're trying to maintain the software in production, it's really not enough to know 404. Like what kind of resource was not found? Like say the engine returns like the user tried to update an object that doesn't exist. Well, I want to know that the user did something wrong. The user tried to update an object that doesn't exist. It's not like the user tried to access an API endpoint that doesn't exist. But it's really important to distinguish what kind of thing was not found. If a bunch of users start requesting invalid API endpoints, I can like intervene. I can look up what was that user and say, hey, you're hitting like /WebSockets, but it's actually /WebSocket. But if the user's sending a bunch of invalid objects, well, there's nothing I can do about that. And then like take HTTP 500, which is again internal server error. Well, there's a lot of different ways your server could have an internal error. That's really, it tells you, it kind of doesn't give you any useful information about it. So what I often end up doing, and you'll see this in the KittyCAD API backend code, I usually end up building my own list of errors. And this is how the backends of Delta Cloudflare worked too. And then I'll have a way to get an HTTP status code from them. So let's import error, and we'll get fuck. Oh, there we go. So file not found, that's going to be four. And this one will be yeah. And now in my HTTP endpoint handlers, they can all return a nice structured error and they can log it. And I can have metrics that actually look at the error variants. But then the users still get to see, an HTTP status code in the HTTP request. And just because you have an HTTP status code doesn't mean you can't give more detailed error messages. Like I could serialize my error struct into JSON, and I could return that in the HTTP body. And that's kind of good practice because the error code is kind of meant to be interpreted kind of by some HTTP client like curl, but the user maybe has more important, more detailed needs. So you can return some JSON and have another consuming it, or you can return, just a random structured error message, an unstructured error message if it's meant to be read directly by a human.
Is the buried hot take in this that like the way the internet does errors is bad? That's what it sounds like.
No, I don't think the way the internet does errors is bad. I just think it's like a starting point. It's not meant to
Mm.
be, you know, the requirements for a status code are not uh
They're the bare
they're not
minimum.
yeah, they're the bare minimum. They were invented as part of the HTTP spec, right? Which is like from the 90s and designed when you were just serving a personal web page. If
Yeah.
that's the case, 500 and 404 and all that kind of stuff is really all you need. But in terms of like the person running the server on the back end, what you consider an error and what the user considers an error are very different.
Yeah.
Because, a pretty common pattern is that we have a lot of different ways our server could go badly, right? We could have a database error. We could have like a Redis error. We could have like fucking like resource not loaded. We could
Encoding error,
be
which is
yeah,
what
yeah,
falls
or
within
like
the.
all kinds of errors, right? And we want to treat all of them separately. We want to log them all separately so we can get nice histograms in our like monitoring framework of all these different errors. But these are actually, from the user's perspective, firstly, we don't want to tell them about any of that stuff. The user should not be able to know if they caused the database error or if they caused a Redis error or something else, because it's kind of a security problem. Like they should, if they've managed to mess up our system, they should not know what they've done. We should just give them as little information as possible. So these will all be internal server errors to the user's perspective.
Sweet.
Yeah, and then for all the remaining ones, we can just say uh,
Oh, I didn't know you could union types in a match like that.
oh, like this. Yeah, you can. Yeah, these are called patterns. Anything on the left-hand side of the double arrow is a pattern.
Yeah,
Patterns can include ors like this.
did not know that. It's cool.
Yeah, it's neat. I mean, sometimes for readability, you want to put them on separate lines or something, but sometimes group them together because they're very logically related. So there's actually, so in Rust specifically, you pretty often find yourself, let's say when I have like, we're using Diesel as our database layer, and you want to convert Diesel errors into this overall error here. So, say I've got like a function, right, to DB. It's going to return. I'm going to do Diesel, like some Diesel call. So here it's trying to convert a Diesel error into my overall main error type here. But we haven't given it a way to do that. So of course it's mismatch types. But what we can do is we can change our database error to have a nested Diesel error.
Sorry, this is a little side note, but how did this is kind of related to error messages, but like
Mm-hmm.
the similar name lint message like that or that
Oh
error
yeah.
message, how do you even accomplish something like that? That seems super useful.
Yeah, it's really helpful.
That's
So
so
Rust
sick.
Rusty has a whole bunch of diagnostics built into it. Like uh there's this guy, Esteban Kuber, who does a lot of work on Rust error messages. And he's saying like really a compiler's main, people always think like, we always think the main job of a compiler is to translate code into machine code, and then also maybe does some error handling and stuff like that. But he thinks like the main job of a compiler is error handling, and it also does some like machine code generation on the side. So I think it's a really interesting perspective to take. It's something that definitely like the KCL parser, there's like a lot of times where the errors are really confusing, and we're going to have to work on those.
I like that perspective. It's like because most of the time you're fixing errors, not compiling code.
Yeah, exactly. Like you should be optimized. Like the sad path is actually way more important in compilers than the happy path for some
Yeah.
kinds of users. There's obviously, if you already know exactly what you're doing, then you just care about like sheer compiler performance, then it's really important that the happy path is super fast. But generally, I think like, especially for a new language, the sad path is actually much more interesting and difficult to do correctly. So we're trying to, we have a function that returns diesel error, and we want it to eventually be converted into our main overall error type. So we can just do, there's a couple of ways we can do this. We can firstly take the result and we can map the error into our error database error type. What is that? Okay, yeah, it's just, and we can ignore the sub error here. I'm gonna get rid of this error 2 part. We can get rid of main at this point, I think. So easiest thing to do is just to map the error, and this yellow underline is just from unreachable code because I used to do above. But we can make it a little nicer because having to do map errors all over the place and having to know exactly which variant to put it into, that's pretty annoying. And then people have to go back to your error definition and look up which variant is the right one to use. So we can just impl from. We can say any diesel from, yeah. And then we can do map error from. And that's nicer to read. But we can even do one step better, and we can just say our question mark, because the question mark will automatically call dot into. It'll automatically do a from conversion if it needs to. And this is really helpful when you have this all over the place, right? If you have a lot of, obviously in this little example, it doesn't make a big difference whether we have out equals, whether we break the error out and do a map error not manually, or if we just use question mark. But in a really long function with 100 lines or so, when you have question marks all over the place, being able to use the question mark to do conversions from a specific error type into your main error type is really helpful. So this is my preferred way to handle Rust errors, to build a big enum of different ways things can go wrong. We can imagine more things like standard IO error being a sub error here. There's actually a really neat library that does this pattern for you. It's called thiserror. So I'm going to add it. I think we just derive this. So we can add, this lets us add stuff like from here. And it will automatically do a from derive for us. So if we take a look at the generated code here, by expanding the macro, come on. There we go. We see, okay, it's firstly implementing the standard error type for our error. And secondly, it's generating conversion code. So impl from diesel error for error. And it's just putting it into the right field for us. So this is really neat because now I can do the same thing for standard IO error. And yeah, it's much less verbose. The other nice thing this error gives you is you can now add your own custom error messages, like And you can even put in the inner message here. You can then put it everywhere. Otherwise, it just uses the debug representation. But by putting in these, we can get a two-string representation. I should probably demonstrate what I mean by that. You understand HTTP error codes now. We've got this example here. Let's get rid of this. So we cannot print E because it doesn't import toString. We can print out the debug representation. No, okay. I think it actually requires you to have like these nice string implementations. So let's put them in. File not found. Did not have enough permissions to write the file. So here we might want to put in the database error, but we also might not, because users probably shouldn't know the details of our internal database structure. So actually, we might just put in here, like internal server error for like all of these. Cool. So yeah, I like the thiserror library. It's useful, and especially when you're writing libraries that need to give structured ways for the callers to inspect the error. This is really helpful. If you're just writing a CLI application where you already know you're just going to print out an error to the standard error and then terminate, then this might be a bit of overkill. But on the other hand, if your CLI tool is going to be used in a big pipeline, you need to, as Frank was pointing out, give error codes. This is really helpful then, because then we can actually give like a different exit code for all of these things. We can have let's give these all just different error codes. Whatever, all the rest we can just put in as 4. And let's make this runnable. We can do standard process exit with the code. This must be I32. And yeah, now I can see that in my terminal, it shows you the error code that it exits with. Exits with the 1 here. But if we change this to an IO error, it exits with exit code 4. And then, we'd have to write some man page somewhere explaining that, what the different error codes mean, but at least now we have structure for it. And I really like this because you can use the same error, enum, and you can have impl exit code for if it's used in a CLI, and you can have impl HTTP status code if it's used in an HTTP server. You can kind of define these like general problems your code may experience, and then for those general problems, you can have like, here's how to show it in a CLI. Here's how to show it in an HTTP server. Here's how to show it to like an end user with nice colored text and stuff like that.
literally making that an implementation detail. That's great.
Yeah, we can always put in, back to show, but yeah. So in terms of, yeah, I just want to bring it back to servers for a second. Say like it's always kind of tempting to unwrap stuff, but yeah, generally servers can take like time to. It takes time for a Kubernetes and then crashes, and then time for it to restart something, and sometimes you have like a restart policy where it tries, to restart it a whole bunch of times in a loop or something like that. So it's better perhaps to just like only panic if really like you want the process to get restarted. And that's a totally valid thing to do, but just, only if no further work can be done in the process. So I'd be very careful about thinking like, is this process going to live for a long time? And if so, under what conditions should it terminate? Like, probably shouldn't terminate error. It should try to handle the errors gracefully. There's this idea of like graceful degradation, where even part of your server is not available, maybe other parts of it should still be available. Like, arguably, we shouldn't crash if the engine is down, because maybe we want to still be able to keep like showing logs, for example. Or maybe there's a temporary error, like the GPU is unavailable or something. And we want to keep it up in case that error gets resolved. In this specific case, actually, we probably just want to kill it and start a new instance, because we don't want users to get stuck on a server that can't be used. But maybe we should terminate the WebSocket in that case and let users choose a new instance, but keep this instance around for debugging purposes. I don't know. Yeah, that's kind of all the Rust stuff I wanted to go through. We can keep talking about error handling more generally, though.
I have a question about our CLI and our Rust library, client library. Do we use any sort of any of these libraries that you've discussed, this error or anyhow or any of those?
Yeah, it's a good question. Let's check.
Are they different? Because I know our CLI is written in Rust, handwritten in Rust, and then our client is generated in Rust. I didn't know if those differed.
Yeah, that's a really good question. Let's take a look at them. This is formatting KCLRs. Okay, first let's take a look at the Rust client for using the API. Yeah, cool. So when we have the let's pick a random endpoint, create file. So async function to create the center of mass and returns a result. Of course, it's a library, so we're not the error message, but you can see it returns this error type here. And yeah, we have an enum with all the different kinds of errors that could happen. So invalid request, you ask for something that's impossible, some problem with the server, etc., etc., etc. And you can see these all have their own structured error fields, right? If there was a problem serializing with Surday, we give you back the Surday error. And we also give you back whatever wanted with its status code. Because in this case, the client can't know ahead of time what status code to give for different errors, but it can always pass on the error code from the server. Like if the server responded with 500 or with 404 or whatever it was, just show that to the user. Let them handle it themselves. So deeper down, we also have like request error being thrown, because that's our HTTP library. Invalid request. This is interesting. It only has a string. And that's because there's not any more structure we can give you there. Like, I'm actually not sure. What is this What circumstance does this get thrown in, Jess? Do you know?
Sorry. Invalid request, not conform. I think that's when like you get a something that isn't like the right JSON. I don't know. When are we doing that? I forget all code that I wrote like a month ago, let alone a week ago, even as
So
well.
it seems like this mostly gets thrown. It seems like this only gets thrown when the request itself can't be cloned, because we need to clone requests for pagination purposes. So I guess if the request is being streamed, if you're trying to like stream a large request over, then you can't clone the stream. So
If it can't be held in memory, is that the idea?
well, you can't clone the entire thing, because by the time you've sent part of it off, it's gone.
Yeah, okay.
But yeah, maybe we should rename this type or figure out the intention behind it.
Like
better.
partial.
Yeah,
Partial send.
something like that. But yeah, apart from that, where we only really have and there's no error message here because we just try to clone. I know we probably could give an error message here because try clone returns. No, it returns an option. So in an option, there's no error message associated with it. It just didn't work. So we don't have anything else to do but say, well, request. Here's that request that you couldn't clone. But on the CLI, on the other hand, let's take a look. I do not know the CLI very well. Run command. Okay, if we got an error from there. Oh, cool. So this is actually using the KittyCAD.rs library, so we can now see how to use those different kinds of errors. So command.run, CLI is ticking. I'm pretty sure this is returning anyhow error. And anyhow, we've kind of looked at it before, but anyhow is like a general purpose. This is just some kind of error. I can't tell you anything more than that library. And so it's good for applications where you know the error is not going to matter anymore, like you don't need to inspect it anymore. But it can be awkward if you're trying to inspect the error with it. So I think what's happening here is we are getting an anyhow error. Yes, you can see this is in fact from the anyhow library. We go to command.run. Right, command is a trait. And when you run it, it returns an anyhow result. So we can then check, we can try to downcast it, which means taking the really general purpose error type and trying to figure out if there's a more specific error type. So if it's a KittyCAD library error, we can match on it, and then we can check what the status code was. We can check, okay, what happened here that went wrong? So if it was an error code about authentication, bidden or unauthorized, then we can give them more specific help messages about how to log in or how to authenticate. Otherwise, just print out the error message that we got.
That's really cool. That's a cool way to like handle having like a really nebulous set of errors.
Yeah.
Downcast ref thing. It's really neat.
So it is neat that anyhow supports this, but arguably we could make this trait return a more useful error type. I suspect if we try to actually dive into this, we're going to discover like why it was so complicated to do. But in Rust, traits can every implementation of a trait can return a different error type. We can just do something like type error. We can have it default to, well, no, let's just put in type error, and then this will no longer be an anyhow result. It'll just be some error type. And we can say it has to implement standard error, maybe. I'm probably going to get a whole heap of error messages. Yep. So let's say this command update. What is this doing? Okay, that's updating the KittyCAD CLI. So here, instead of returning anyhow result, we could give our own like update. Well, firstly, we could just choose to, do a normal. We could always just use the normal anyhow error type we were using before. And that works fine. But if we wanted to do a more specific type, we could then put in here our own like update error. And we could have an update error with all the different kinds of errors that can happen. So instead of saying under homebrew here, we could just replace this with this. Of course, then we need to say, what was that error message that I just destroyed? You're running under homebrew, please run. Yeah. Oh, we call it update error. And then we have to map this is under homebrew function to also map to our main error message. And so you can see this does get kind of complicated if you have a lot of different possible errors that could all be happening in different ways. So right now, like I count, this result is from anyhow. We're only, yeah, this error here, where you're running under homebrew, that can be happening from either like we run homebrew -- prefix. And so you get an error from like that command could fail for any reason. It's just some Linux command, you might not have it installed, whatever. And then we try to parse the output into a string.
Different kind of error.
Yeah. You can see that like these errors can be pretty complicated. They're all slightly different types, and you have to really think carefully about them. But that's kind of one of the strengths of Rust, is that you can use a library like anyhow, just say, okay, it's an error, I get a string for the error, that's all I need. And then if you want to go back and make it better, you can then go and structure your errors more nicely than that. Or, if it's like a mission critical application, you really have to understand every single error properly, then you do it right from the start. Like with API Mon, the end-to-end API monitoring service that we have, it's really important that if there's an error, we know exactly why, so we can diagnose it. So that, from the start, has had like a giant nested error enum that has a lot of different cases. But if I was spreading the KittyCAD CLI, at the end of the day, like the user isn't going to take a different action. The user is not using KittyCAD CLI inside some script. They're just going to be running it, from the terminal, trying to convert stuff. If we get, so in that case, it's fine, just show an error message and explain what went wrong. And so anyhow is a great choice for that. On the other hand, if users start to use KittyCAD CLI as an ingredient in really large, complicated scripts, and they want to like match on different exit codes, at that point, we might want to replace the anyhow stuff here with this error. Yeah, thanks for suggesting we look at the actual code here, Frank. This is very interesting.
This is definitely a can of worms for another day, but the idea of having a concept of this in a trait kind of broke my brain, because it feels like this is front end guy ignorance, but that feels like object orientation, and traits feels like something has always in my head meant something pretty different. But I think that the idea of having like a this error in that trait was what broke my brain for a second.
Oh, just like the word, like the library name, this error?
Oh no, your implementation, you had like
When we
a
had the type.
an
Yeah.
internally defined error type here.
Yeah.
Um, yeah, that seems super interesting for future reference.
Yeah, we could definitely do a whole nother session about associated types because they're really powerful, but they definitely they can take a little to get used to. But the idea is that, basically every implementation of a command might want to use a different error type. So we let them parameterize when they say, I'm implementing command, and the way I'm implementing it is that error equals anyhow error, or the error equals I32, and I'm going to give you an error code, something like that. So it lets you more flexibility about exactly how you're going to implement the trait.
Which is
This
probably really powerful for library code, especially, right? So that someone can slot. It's like a slot.
Yeah, it's like a slot. Yeah,
We have that in like Svelte and other like front end libraries where you're like you want to have a component that can be reused, and then its children can, or different slots within it can take whatever component you want. So that kind of is my way of thinking that.
Yeah, I'd say there are all kind of ways to like extend, like have a trait where you don't know ahead of time all the ways the user is going to use it. But the user, as long as they use it consistently throughout their application, they can use their own specific types for it. So, for example, the yeah, it works nicely with generics basically, because you can say I'm going to be generic over command, but that command has to use my error type, or has to use the I32 error type, or something like that.
That's really cool.
Yeah, so we get like, yeah, we can go into that. I think that's a good topic for next week, maybe. Advanced traits.
That sounds cool.
Cool. Anything else people want to go through on errors in Rust? Okay,
I like this
cool.
error for tests as well. It makes writing tests a little bit easier when you have special cases you want to check for in a test. Like it's much easier to check for an enum variant than it is to like inspect the string and then like check for words in it or whatever.
Yeah, totally. Yeah, it's much easier to just do something like, to do something like, because now if you get a different error type, it'll show you, it'll say, I got my error dot dot foobar, not my error command not found. And you have to update all of your error messages whenever you change the string.
That's cool. Yeah.
Yeah, much more helpful. Okay, cool. I think we'll call it there. Thanks for
So much.
rusting, everyone. See you all next week.